Okay, great. So today I want to do a talk walking you through how I created MuJoCo.jl. So this isn't specific to the package MuJoCo, and I just thought this would be useful for anyone who might want to wrap a C library and access it from Julia. So this is some work I did with a colleague, Nick Barbara, at the University of Sydney. So a very small amount on what MuJoCo actually is and why we actually want to access it from Julia. So this is a really short video. It's not my video. This is from a group at DeepMind. And they're able to sort of train these simulated agents to play football. And this is a really cool application. And it's reliant on the actual physics simulation underlying it and the visualization techniques inside as well, which is what the MuJoCo engine does. And we thought we want to do things like this, so we want to access MuJoCo from Julia. So our other option would be to use like the Python API, and I'm sure everyone doesn't need me to explain why we didn't want to do that. So what I want to talk about today is sort of how you can replicate this process, maybe for a package that you're interested in and that's sort of specific to your field. So first of all, we'll go over what a JLL actually is and how you make them. You might have heard this term a lot, so hopefully you'll know what that is by the end of the talk. And then we'll talk about, once you have this JLL, how do you actually use it? How do you call the functions that you've taken from the underlying C library? And then also, how do you make this actually easy to use on the Julia side of things? So to create a JLL, I would recommend you use Binary Builder. There's nothing special about a JLL package. All it has in it is a sort of specification of all of the artifacts, which are like the precompiled binaries or shared libraries that a user would need on their platform to be able to use the code there. And you can create this manually. Don't. It's not worth it. Instead, you can use a brilliant package called Binary Builder, which has had a few talks at this conference already, and it makes the process far more straightforward. So to actually use it, you just install the package like you would any other package, and they have a wizard as well, which is sort of an interactive workflow where you can specify which package or which source code you want to download, and you write you have an interactive bash script on a Linux platform that you can use to actually compile the code. And what it will do is it will generate a file called buildtables.jl, which is just a script that takes the steps that you did in the wizard and makes it into just a Julia script so it can be reproduced. And I'll go very quickly over what this script is. So you just define the name of your package and some versions. You tell it where to find the source code. You give it essentially a bash script that will compile your source code and create your shared library. You tell it that it will create a shared library, for example, and you can also specify executable binaries as well. And then finally, it just calls the buildtables function. So what you can do is you can run this script with some arguments from the command line and deploy it to a local package on your system. And I recommend deploying it locally first just to test things out and see if it works. But ultimately, what you want to do is create a PR into this repository. I think it's called Yggdrasil, but I don't know how to pronounce it. And this is just a big repository full of these build-table scripts for all the JLLs in the Julia ecosystem. And when someone approves your PR, it will get merged into this repository, and they will run your script and build it for all the platforms, or build the JLL for every platform, and register it in the global registry. So really, you don't have to do much at this stage. So once you have your JLL, how do you actually use it? The JLL doesn't contain any actual Julia code that you can call. All it has is these artifacts for a specific platform, and some code that like loads them into memory when the user loads your package. So for that, we turn to clang.jl, which is a really good package for actually generating your binaries. And so what we want to do with this is create a package that the user would load in. So instead of loading your JLL, you load your package like MuJoCo. I recommend you use PKG templates to create the original source. There's documentation on the webpage, but you'll get a directory structure that looks kind of like this. And then what we want to do is create a folder where you can sort of put all your scripts and all of the code to generate the source code automatically. So I recommend creating a new environment for this. And you also need to specify this TOML file, which is just options for Clang. On their GitHub page, they have an entire file that tells you every option and what each option means. And we also need to just write a script in Julia just to actually run Clang. And this is what the script looks like. It's pretty small. All it's doing is loading the JLL that you've built before and Clang. And then what the JLL will contain is the path on your system to where all of these binary artifacts that you built with Binary Builder, where they are on your system when you add the package. And this will give you also the headers from the library. And together with the options that you specified for Clang, you can build the actual bindings. And so what do these look like? They essentially just look like very thin wrappers around a C call. So for MuJoCo, there are literally like there's about 300 functions. So I didn't want to write this for 300 functions and then manually specify what each of the types were, so Clang can save you a lot of time here. It also converts all of the C structs into Julia structs. To be honest, they're pretty one-to-one mapping. But again, it's not something that you want to do manually. And it also converts things like enums as well. So having that, you get a very C-like library that you can call from Julia. So with the few minutes that I have left, I'll just sort of explain a few things that we did to make this actually easier for users of MuJoCo to use. So the first thing is no one really wants to manage pointers, right? You're in Julia, it's a memory managed language. You don't want to have to free every pointer that you make from your library. So Julia has a way of, in the constructor, you can specify like a finalizer or a destructor and point it towards the C function that will free the memory correctly so you don't get any memory leaks. I would highly recommend people do this. Also, MuJoCo has a Python binding, so they can. So it had a bunch of documentation in there that we could just scrape directly from the source code, and we basically wrote a script to generate Julia source code for the documentation. And you can also override these methods: get property, set property. So instead of your users dealing with pointers, you can convert them into objects that they're used to, like arrays, for example. So this slide just tells you the roadmap of what we've discussed. And if you want to access the slides afterwards for reference, you can have a look at this QR code. Great. Thanks for listening. Anyone have any questions?
Thanks, Jamie. So we have time for 1 or 2 questions.
Handle C++ can it handle C++ as well, or only C packages?
So if you do a C++ package, you'll use Binary Builder exactly the same. That would be fine. But to generate the bindings, I think there's a package called CXX wrap instead that will do it for the C++. Okay. And it actually looks quite easy to use from the documentation. So you just swap out the Clang step with the CXX step.
Okay, thank you.
I mean, you need a C ABI. So you might, if the C++ package has a C API, then you can use that also.
Hi. Did you by any chance use anything from the previous MuJoCo.jl package that was in Lyceum?
Yeah, so we used a lot of their visualization code, which basically it was like a thin wrapper around their. MuJoCo had a bunch of C functions that called OpenGL, and it was essentially calling a lot of that code. So yeah, we took the code for the visualizer over, but we remade the entire library from scratch apart from the visualizer.
Okay, thanks, Jamie.
Great. Thank you, everyone.